Today we're continuing to look at solving stoichiometry problems so we can determine the amounts of chemicals involved in a reaction. And this time we're going to take a look at gas stoichiometry. So we're going to use ideal gas law so we can solve for volume, pressure, or temperature during a reaction. So gas stoichiometry works pretty much the same way as gravimetric stoichiometry, and it's also often combined with gravimetric stoichiometry, because we can use volume, pressure, temperature, molar volume, ideal gas constant, all of those things to figure out how many moles of a chemical are present within a gas. That means that if we have a gas that's a part of a chemical reaction, we can use that information to determine how much of that gas is reacting. And we don't have to calculate in grams. It might be more useful or more important to calculate a pressure or a volume or a temperature that it needs to occur at. So when you're doing these calculations, it's important to remember the molar volumes. We did these in the gas chapter, but I'm going to remind you about them right now. At SATP, the molar volume of any gas is 24 8/10 of a liter per mole. At STP, it is 22 4/10 of a liter per mole. You should also remember R, our 8.314 kPa liters over moles degree Kelvin. And remember, if temperature is involved in these calculations, you have to do it in Kelvin. You cannot do it in Celsius, you cannot do it in Fahrenheit. So our first step for any gas stoichiometry problem is going to be to write out a balanced chemical equation. Always, always, always stoichiometry has to start with a balanced reaction. After we've done that, we're going to list out our knowns and our unknowns. Then when we're actually doing the calculations, we're going to first solve for the number of moles of our known compound. We are going to use the molar ratio to then convert that to the number of moles of our unknown compound. And then we'll solve for the final volume or mass or temperature, whatever it is that we need. Another important thing to remember also because of that is that the gas portion of this problem might be the thing that you know, it might be the thing that you don't know. It could also be both. So you got to be careful which one you put your certain numbers with.